After we have seen an atom is made up of the three subatomic particles and the position, then now we start dealing with every subatomic particle, the way they are arranged. So we start with electron arrangement. We have seen electrons revolve around electrons, and in the nucleus, in the orbit. How are they arranged? How are they arranged? That is called electron arrangement. In 1913, Niels Bohr suggested that electrons orbit the nucleus in the special regions called shells. Electrons revolve around the nucleus in the special region called shells, or also known as energy levels. Shells, this is the specific or specified region where electrons pass through, called shells. Or in other words, we call it energy level. And this energy level should be at a fixed distance from the nucleus. Not only the distance as you think. It is a specific distance. And that distance must be fixed. And that is why are at the fixed distances from the nucleus. So electrons revolve around the nucleus in a specified region, special region called shells. And every shell from the nucleus, it has that fixed distance from the nucleus. Now, each shell can only hold a specific number of electrons. You see? So it is not randomly. Every shell must have specific number of electrons. So the number of electrons which are occupied in the first shell is not equal to the number of electrons which are occupied in the second shell. So every shell have got different number of electrons that have been occupied. And that is why there is a formula that will guide us. How many electrons does it hold? Does it hold in a specific shell? Because we are saying each shell can hold only a specific number of electrons. The maximum number of electrons held within each shell is determined by using this formula. 2n squared. 2n squared. Where n is the position of the shell from the nucleus. If the shell is the first one from the nucleus, n is equal to 1. If the shell is the second one from the nucleus, n is equal to 2. For example, according to this formula, the first shell can hold, that is to say, n is equal to 1. But the formula is 2n squared. Means this is equal to 1 squared. Therefore, it is 2 times 1 squared. That is equal to 2 electrons. Now, the first shell occupies 2 electrons. It won't go beyond 2 electrons. That is the maximum number of electrons that are must occupied in the first shell. Not more than 2. Not more than 2 electrons in the first shell. But it may be less than 2. But the maximum number of electrons that are held in the first shell, only 2 electrons. It may be less than 2. That is 1. But not more than 2 electrons. According to this formula. For the second shell, you may see it is here. Means n is equal to 2. From 2n squared, then it is 2, then times 2 squared. 2 squared is 4. 4 times 2 is 8. Now, for the second shell, the number of electrons that are occupied in that shell, we have 8 electrons. We have 80 electrons. It must be not more than 8 electrons, but it may be less than 8 electrons. That's the capability of the second shell to occupy. How many electrons are there in the second shell? The maximum, we have 8. It may be less than 80, but not greater than 8. And for the third shell, means n is equal to 3. That is 2n squared. That is 3 squared. Now, 3 squared is 9. Times 2 is 18. So we have 18 maximum number of electrons which are occupied in the third energy level. Means it may be less than 18, but not greater than 18. Because the capability of the third energy level to occupy electrons is only 18 electrons. The same applies to the first one. 4 times 4 is 16. Times 2, that is 32. Now for the first energy level, we have 36. And so forth. Then the first 4 shells are represented by letters. We have K, L, M, N. K, first level. First energy level with 2 electrons. And this with 8 electrons. And this with 18 electrons. And this with 36 electrons. Not more than 36 electrons. But it may be less than. But there is a reason in such a way that the third one is written with 8. Because it seems to be stable. An atom seems to be stable with 8 electrons when it is written on the third energy level. Than 18. That is why, if now you're talking about potassium with 19 electrons, means the first one is the 2. The second one is 8. And what next? We have 10. Then if it is 10, we have left with 9. We were supposed to write here 9 instead of 8. But this is not be stable. So we write with 8. Then left with 1. This is how we write the electronic configuration. So electronic configuration is written from the number of electrons that we are having. Are we together? That is why you can see first, second, third, and fourth. This is the nucleus. Each electron in an atom is in a particular shell. Every atom must be in a particular shell. We don't have random electrons. Every electron must be in a particular shell. And if that is the case, and the electrons must occupy the lowest available shell nearest the nucleus. This is according to Aufbau principle. Aufbau principle means, and also a shell which contains its maximum number of electrons is called the filled shell. If now you find the shell is filled, with the maximum number of electrons, we call it filled shell. Because it has got its own maximum number of electrons. It is filled with electrons. Are we together, Harrison? It is filled with electrons. And that's why we say a shell which contains its maximum number of electrons is called a filled shell. If it was supposed to be 8, now it is 8 exact. Now this is filled. Then electrons are arranged so that the lowest shells are filled first. This is according to our principle. You must fill the first one, Once you have filled the first one, and you have left with another electrons. Example, now we are having potassium. Okay, that is potassium. Having 19 electrons. The first shell is 2 electrons. Means you must fill first the first shell. Then the rest of electrons are taken to the second shell. That is 8. So you have to fill the second first before you go to the third one. That is 8. Then once you have finished it, this it is. Now how many shells? We have the first, the second, and the third, and the fourth. Now we have 4 shells. But we fill according to the principle. The first shell with 2 electrons. The second shell with 8 electrons. The third shell with 18 electrons. But it is said to be more stable with 8 electrons instead of 18 electrons. So this is the formula. Electrons are arranged so that the lowest shells are filled first. That is Aufbau principle. So you fill the one which is nearest to the nucleus first. Then once it is filled, you go to the second one. Once it is filled, you go to the third one. You won't start with the third one while the first one is not filled. You won't start with the second one while the first one is not filled. So diagrammatically means you are having 2, 3, 4 shells. Now this is the first, this is the nucleus. Then we are having the first shell. We are having the second shell. We are having the third shell. Then we are having the fourth shell. But this is the nucleus. This is the nucleus. Now the first shell is having of 2 electrons. You write them. 2 electrons are here in the first shell. Then the second shell, 8 electrons. Write them in pairs. That is the principle. Pairing of electrons. So it may stay stable. Therefore, we have 2 electrons here. 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 So we have 8 electrons but 4 pairs. Then the third one, we have 8 electrons. Write them in pair. Write them in pair. Write them in pair. Write them in pair. And then let's see, we have only 1 electrons. So this is the diagram in which we represent electronic configuration of potassium. What if now we're talking about chlorine? That is chlorine. Now, number of electrons in chlorine. The position of an atom. That's number of electrons. We have something to discuss so far. Now, 7 electrons are there. So, we are having 2, the first one. Then out of 17, we have left with 15. Then next is 8. Then we have 10. We have left with 7. So, we write here 7. Make sure that the first energy level occupies 2 electrons. Not more than 2. The less you take to the second energy level. Now the second energy level must occupy only 8 electrons. If now you have left with 15, you write 8 only. The rest you take them to the next level. That is 7. Therefore, we are having the first shell, the second shell, and the third shell. So, diagrammatically, this is the nucleus. Then, we have the first shell, we have the second shell, we have the third shell. This is what we got. But remember, the first shell, 2 electrons. The second shell, 8 electrons. That is 4 pairs. And the third one, we are having 4. We are having 7 electrons. So, means we are having 3 pairs and 1 as a single. So, this is the 2, 80, 7. But this is the 2, 80, then 80, then 1. Another example here. Calcium, now that is calcium. That is 20 number of electrons. If it is 20 number of electrons means what? Now the first thing is 2. The second is 8. Now it is 8. Then we are left with 2. So we have 4 shells. Then we draw diagrammatically. Now this is the nucleus. Then the first shell, the second shell, the third shell, the fourth shell. Now the first occupies 2 electrons. The second occupies 8 electrons, 4 pairs. And the third one, the same thing. Here it is. And the last one, we're talking about 2 electrons. Now, this is the electronic configuration of calcium. 2, 80, then 80, then it is 2. So from here, we can determine a lot of things. We can determine the valence. We can determine the group now, the group for an atom. From writing electron configuration, we can determine so many things. But that is not our intention. Our intention is to know how these electrons are arranged. So this is how we arrange electrons. And this was according to Nellis Boyle. He discussed that electrons revolve around the nucleus in their special region called orbit. And that orbit is called, in scientific language, we call it shell, also known as NHF. And every shell must occupy the maximum number, means the specific number of electrons. And they have the fixed distance from the nucleus. And according to Rafal principle, means the lowest one is filled first before you go to the next one. And the lowest one is from the nucleus, not from here. So that is very important for you to understand. So that's all about the electron. And it's therefore now we come to conclude by saying the electronic configuration is the arrangement of electrons in different shells. The way you arrange electrons in different shells, we call it electronic configuration. So you are configured. To configure electrons, it's all about arranging electrons in their different energy levels. This is how we arrange them. So you got to be very careful when talking about arranging